So let us now learn how to actually build a calculator. So first you have to ensure that your Android manifest is correct. So here in my application root I have a calculator activity defined with intent filter android.intent.action main and category android.intent.category launcher, which will allow my activity to be displayed in the launchers. That is where you can start your apps from. And then I have also specified how it will be displayed. So it's like Android name is calculator, and then I can also write Android label is equal to calculator. This will be text that will be displayed. You may also specify custom icon from the rest folder. Now coming back, we have already defined a layout for our calculator. Now we need to focus on the processing part of it. So this is our calculator activity. So first I have used the Bean shell, that's an open source library for my calculator. So in my build.gradle of my module, that is usually the default app, I have compiled org.bean shell, and whenever I sync it, because Bean shell is available in the jmarvel directory, it is automatically downloaded by the Android Studio and built into my application. So you write compile space, in single quotes you write the name of the library. So all set, I can now use Bean shell along with my calculator. Now I have first declared a public interpreter, that is a instance of a Bean shell which comes along it. As you can see here, import bsh.interpreter. Then I have defined all the buttons. I've got then the text views, I've got reference to them, as you can see here. Now you may also see some code like this, which is actually for the widget that is also built upon the same calculator app, which we'll learn later on. Now I am setting on-click listener, so let me expand this for you. So basically I can set an on-click listener dynamically in the code. So for each button I am setting an on-click listener, and I am passing new view.onClick listener function as an argument into b1.setOnClickListener. This can be done with almost any element in Android Studio, and in that I have to override, that is I have to rewrite a previous method, that is public void onClick, which accepts a view as I told you before. Now in every button I am trying to first get the reference to the button, so I am casting the view into a button so I can use it as a button. Then I will use string input is equal to h.getText.toString. So this can be done with any element that behaves like a text view, even edit text also. And this is the way you will be getting the text the user has entered even in an edit text. So then I write a exp, which is the text view, to set the label as exp.getText.toString. So first we'll get the existing expression that the user is inputting, then we'll add the input string, which is the operator that the user has put. Then inside we are also maintaining a string called flow, which is maintaining a kind of expression internally, and then we set the typing is equal to true, and this I have done for all the buttons respectively. You must memorize this general syntax, as this will be very commonly used in the Android programming. Then somewhere you might see me using hard-coded strings like dot, as if I were trying to get the text of the button, it may not work well with my interpreter. Also then I have to apply the app logic into it, so I have written clear is set on listener. So whenever somebody places clear, I set typing is equal to false. I reset my internal flow, that's the statements going into the application. Basically flow is my variable, which is a string which will be evaluated whenever the user presses the equals to button, and I set all the labels as empty. As you can see, this is a code retyping. Then I set equal.setOnClickListener. First I am using log.d. So basically when I am running my app from the Android Studio, it will show me in my Android monitor the log.d comments. So this is basically a part of debugging. You may also use a toast, which is made in the activity by typing toast.makeText in the bracket. The first parameter is the reference or the context in which the toast will be put. Toast is basically a kind of a pop-up that you commonly see in Android. The second parameter is the string, which has to be toasted or shown, and then third parameter is the length. So there are two type of length that you should use: toast.length long and toast.length short. And then you finally use the catenation property of Java and call the show method to show the toast. So moving on, now I'm putting try catch block, which is a property of Java. So basically in try, if any error occurs, then the program does not interrupt unexpectedly, rather it raises an exception, which is an error, and we try to catch that error and try to handle that error. In my case, whenever you press equal to and my calculator is unable to determine the output, so it will raise an error, which will, I'm using e.print stack trace, which will be also displayed in the Android monitor. Then after the user press equal to and all the answers are shown, the expression text is set to null and the typing variable is set to false, which is of Boolean type. So it can hold the true or false. So what we are going to try, or we are going to try to execute it when the user press equals to. So we are saying that if typing is all true, then we are making a string string, then we use the execute function, pass our expression string. You may also pass flow, but I have designed flow in this calculator as I am making it future ready. So if you are making any updates, fixing your rapid work, so it may help. Then we are using getting the answer in fin. We are using ANSV, which is a text view. We are using the set text and passing on the answer as string. So the answer will be displayed as we set text of the answer label, which is currently showing the answer. So this was how the calculator will interact with the UI. Now that I have a protected function called execute, which will again try to solve the expression that the user enters. So if flow is not empty, or flow is not equal to null, or flow does not contain any semicolon, which may arise due to many calculation, I have already declared an interpreter I. So I will use that interpreter I.eval. Then I will pass a string. So basically when I am calling the eval function in my bean shell interpreter, it will run this string as a code in its Java interpreter. It will run this as a Java code. So I am typing result is equal to whatever the expression is there. So whatever the expression, it will get evaluated and stored in the variable result. Then I create an object answer is equal to I.get result. These are all the properties of the bean shell interpreter that I am using, a third party library. And I declare that all the coding libraries and all the hard work done by the bean shell interpreter and its creators are an exclusive property of their own. Though it is open source and you can use this in your application, but you must not try to so purely sell it as your own property. Moving on, I try to get result. So my answer is an object and I get the result value in that, and then I cast it to a string by typing answer.toString. Then I make a toast to display the answer and return fin. Else if this cannot happen, then I try to return null, and then I catch any value. Then I try to pop up the error as expression is incorrect, which is usually the case if it is not going through all this successfully, and then also again I return null. So this was our calculator. Now you might see the working of the calculator.